Hi, in this video we're going to learn how to solve and graph inequalities. Now it's fairly simple and it's very related to what you've already done. So I'm going to start by boxing my variable, and I need to get rid of this positive 3, so I'm going to subtract 3 from both sides. This 3 cancels and that gives me 2x. Now, before we were using an equal sign, this time we have a greater than sign, so I'm just going to bring it down, just like I would with the equal sign. 7 minus 3 is 4. Now I need to divide by 2 to undo the multiplication, and x is greater than 2. And I know it's greater than because 2 dots are greater than 1. Now I need to graph it. So I'm going to put a number line on my paper. And I'm going to put the number 2 there, and I need a number smaller, so I'm going to pick 1, and a number bigger, I'm going to pick 3. I'm going to put an open dot over the 2 because it's not equal to, it's greater than. Greater than 2. Which number is greater than 2? 3 or 1? The 3. So I'm going to go in that direction, and I'm done graphing my solutions. That means x can be 2.1, 2.5, 3, 4, 7, 8, anything that's bigger than the number 2, and it will make this expression true. This inequality true. Let's look at another one. Same thing. We're going to box the variable. All right, what's the next step? We should add 5 because what gets rid of a negative 5? A positive 5. These 5 cancel. 9x is less than, and I know it's less than because 1 dot is less than 2. And this is 72. To get x by itself, I divide by 9 to undo that multiplication. And now I have x is less than 8. Again, I will make my number line, and I'm going to put the number 8 on the number line, and a number less is 7, and a number more is 9. There's no equal to, it's just less than, so an open circle, and it's less than, so which number is less than 8, 7 or 9? 7 is, so I'm going to shade in this direction. Okay, now this one is slightly different. I have negative 3x plus 7 is less than or equal to 28. I'm going to box my variable. I'm going to get rid of positive 7 by subtracting 7 from both sides. And the 7's cancel. And I bring down the negative 3x is less than or equal to 21. And I'm going to stop for a second. To get x by itself, I had to divide by negative 3. And there's two ways to think about this. When we look at algebraic equations, we think of balancing the sides on a scale and keeping things equal. Well, somebody thinks of it this way. If it's negative, then it's like gravity pulling on the shape, and so the shape is lifting up, which throws the scale off kilter, off balance. And to balance it, you need to get rid of that negative, put a force on both sides to balance out that negative. Another way to think about it is everything is relative to its distance from 0. So when I divide by negative 3, I'm changing my direction. I'm making a U-turn on that number line. And when I make a U-turn on that number line, I'm going to go from less than to greater than. So whenever the coefficient, and that's the number with the variable, whenever the coefficient is negative, just when the coefficient's negative, I need to remember to switch my inequality symbol. So my answer is going to be x is greater than or equal to negative 7, because I made a U-turn. I flopped around the number line. And again, to graph this, I draw my number line. I'm going to put negative 7 on the number line. A number smaller is negative 8, and a number bigger is negative 6, and that's because it's better to owe $6 than it is to owe 8. All right, greater than or equal to. So I'm going to color in my dot this time because of the equal to. That's what that little line under there, equal to. And it's greater than. Which number is greater than? -6 or -8? -6. So in this direction I go. All right, 2 more practice ones. Here we go. Throwing this one in to make sure we remember what to do. Okay, to get rid of +3, I'm going to subtract 3 from both sides. And I have x divided by 5 is greater than -1. To get rid of division, I'm going to multiply by 5. This time the negative is over here. It's not with the variable, so I don't have to worry about flipping my symbol. It's going to be x is greater than -5. And of course, we'd follow it up with a number line, but I'm going to skip that step for this one. And our last example, we have the 7x minus 3 is less than -10. So I'm going to add 3 to both sides. And that gives me 7x is less than -7. Again, I did not flip the symbol because my coefficient, my number with the x is positive. Okay, so I'm going to divide by 7, and x is less than -1. And I know I said that was the last one, but just want to show you one more thing. Sorry, this screen's a little boring. We're going to have -x over 7 plus 2 is greater than 3. Okay? Now, see this negative? I want you to move it from the x to the 7. Okay? There we go. And we're going to always keep the negative with the number part. So now what I'm going to do is I'm going to subtract 2 from both sides to get rid of the +2. And I have x over -7 is greater than 1. To get rid of the division, I multiply. Now I'm multiplying by a -7. The number that's with the variable is negative. So what do I have to remember to do? I need to remember to flip my symbol. So x is less than -7. I know you know how to solve two-step equations. This is just a step up, solving some inequalities.